Hey everyone, my name is Zichuan. Today I am going to talk about a new C++20 feature called Concept. Before we continue, I need you to fully understand template first, because template is basically a further step of template. If you're not quite familiar with template, you should close this video and come back later when you fully understand template. The way how I understand the concept is how we add constraints to templated parameters. If the constraints cannot be satisfied, the code won't compile. In this video, we are going through 3 examples and we will talk about how it works and what the syntax looks like. Here's the first example. We have a template function, it's called squared. It takes in a value and return the value multiplied by itself. We can test it. Let's see, all the results are all correct here. But is this function perfect? The answer is not, because it can accept anything for this num type. But actually, what if this value is not a number at all? Let's see an example testing class here. We have a class called full. It supports the multiplying operator and cout operator just for showing the result. And let's declare a full with and we call this function and replace it by full, and we run it. Now we can see the square is actually taking in this full object, treating it as a number and output it without any error log. Is this what we want? No, I don't think so. The square in this function is defined to accept value as numbers. And is there a way for us to add constraints and limitations to the parameter to make it only accept numbers? The answer is yes. It's called concept. It's in C++20. Now we go to Solution Explorer. We need to change the properties. We need to change the language standard to 20. Let's apply that. And we need to include a header called concepts. Okay, here is how the syntax works. Now, first of all, we declare just like normal template, and we do a num type. And here we use keyword called concept here, and we give it a name. We can say numeric. It can be anything reasonable, and we do an equal sign. Here we do, and on the right of the equal sign is the definition of this concept. In our case, we want this squared, the parameter needs to be a number, so it has to be either a integer, or a floating point. Yes, floating point type. Okay, this is how we define a concept, and let's replace this with our concept. Let's remove this line and we replace the num type with our numeric and add keyword auto. Same thing for here, auto. And now we can see line 57, this square of full doesn't compile anymore because see, the associated constraints are not satisfied. This full is not an integer or a floating point. That's why it's not compiled. If we comment this line out, and see, it compiles successfully. Okay. For example number 2, we need to add 2 classes to support our theory. Now, we have a class called bar, and another class base, which is inherited from bar. Now, for example 2, inheritance, say we have a template function that I wish the object we pass in has to be a subclass of bar, because I want to call the specific API that bar offers. Say concept can solve this problem for us. As usual, we declare a template or declare a concept first, plus derived type class base type. Here we use concept keyword and we name it like derived from anything reasonable, and std yes base of b base type derived type. Okay, here's how we declare the concept for our purpose. Note, now for line number 73, note this. We change the class, we do this. Now, by doing this, now example 2 inheritance has to pass in this object as a subclass of bar to make this compile. I am going to test that. Okay, example 2 inheritance, we call full base bar for each base. Okay, Visual Studio already told us the answer that line number 94 doesn't compile because for is not a subclass of bar, where bar and base they are. So let's try to build, and it will say the associated constraints are not satisfied. And we comment that out, and we're going to call this function. The compilation is succeeded because bar and base they satisfy this constraint. They derived from bar. Okay, for last example for today, for concept is move semantics, and in this bar class we have deleted the move constructor and move operator equal. Now let's see, what if we want a function that the parameter has to be movable, and we do that. We can do that like as usual, template plus type, the concept movable type equals cd, and C++ already give us useful APIs type, and cd yes move constructible type. Now here we declare the function that we do template, and note here number 85 we use movable type and movable object. Okay, let's see, sorry, I should name this better. We should do this type. There we go. And in this function, let's see, example 3, example movable. See, we use movable as parameter object, and we should take the right reference. And here we can try the code by doing this. New object std move object. So this will only compile if we can actually move to call the move constructor, and we do the test like this. Again, example movable base. Okay, full successfully compile, and we do base first because it compiles, and last for bar it deleted the move constructors and move assign operator. Let's try to compile. Now we can see this cannot be compiled because it doesn't simplify. The move constructor are deleted and cannot call this function. Okay, in conclusion, concept is a way we add limitations to our template function, and if the limitation doesn't stand anymore, the code won't compile. Thanks for watching, and I will see you next time. Goodbye.